Hello, good day. My name is E and I'm a representative of I.F.Mathematics.Academy, IFMA. And today we're going to be talking about the differential calculus. And under this, we are talking about the application of the first principle. Now, if you can remember in the last video, we applied and established the first principle. And you can see the link to the previous video down at our description there. Now, today we're going to be moving forward by applying this example, which is so this is the example or the problem that we're going to be working with using the first principle. Now, first step here is going to add the change in y and add the change in x here. So that's going to be this is what, after you add the change in y and the change in x to both sides of the equation, this is what it should give you. Now, we're going to expand this. So if we expand, it should give us and this is what it should give us after we expand, because x squared plus 2x change in x plus change in x squared. So now we are going to make the change in y, the subject of the formula. So that is going to be we all know that y equals x squared, so we can replace y as x squared. So therefore, we have, instead of y, we are going to put x squared. Now, if we examine this equation using our roots principle, which means read, understand, think of the solution, and solve. So therefore, once we've read the question, now we understand it, and we can think of the solution, and so far we can see that x squared cancels out x squared. So this is going to be this, and we are left with 2x, the change in x, plus 2 plus the change in x squared. So that will be this is what it should look like after the cancellation. So now, applying the first principle method, we are going to divide both sides of the equation by the change in x, or delta x. So therefore, we have and after dividing both sides of the equation, we should get and the reason why we get this is because change in x cancels out change in x. And one change in x cancels out two change in x's. So this is the same thing as times. So this cancels out this, so leaving us with this, and that's how we have this. So therefore, we have 2x plus the change in x. Now we can get our limits as as this means as change in x tends to 0. So it's going to get to a point where change in x is going to meet 0. And when that happens, change in x turns to 0. So therefore we have because as we said earlier, change in x can also be referred to as 0. So therefore we have this. And so our differentiation using the first principle of this example should lead us to and this is our answer. So let's take a quick recap. We picked a problem, and the problem was y equals x squared. So therefore, we added the change in y and the change in x to both sides of the equation, and then we expanded this side of the equation, and it got us this. And then we made the change in y the subject of the formula. Then we also established that y is also x squared. So therefore, y can be rewritten as x squared. Now x squared cancels out x squared, so we are left with 2x changing x plus changing x squared. And then, according to our first principle in our differential calculus, we said changing y is going to be divided by changing x, and that's going to divide all sides. So we're going to divide all sides by changing x. And after that, after our division and cancellation, we got our answer as this. So therefore, we're going to take the limit, and the limit of changing y over changing x as changing x tends towards 0 will give us this. And our dy dx equals 2x plus 0. So we can also write that as dy dx equals 2x. And so far, we've been able to solve one problem more using our first principle that we established in our last video. So if you didn't see that video and you do not understand fully, you can go back to our description and click the link to the last video where we established the first principle. Now we just solved a real life problem here. And for more videos, please follow us on Instagram, Twitter, Facebook, and subscribe and like our videos. Also share with your friends and your family that need mathematics help, because we are a community of math lovers that love to help other people. And we hope to see you again next time. Thank you.